Okay, folks, we're back. This will be Moonscapes number 39. We're coming up on totality in about 6-7 minutes. I have a couple of people with me here. Your name is?
Chelsea Bordeaux.
Chelsea?
Yep.
Okay, a little closer so everybody can hear you.
Chelsea.
Okay, and you can ask me anything you'd like, and I can tell you, and if I don't know, I'll make it up.
Okay.
This your first eclipse?
Yep, this is my first eclipse.
First time, yeah. They're actually not as important as they used to be. They used to use them for they used to time actually they still do. They time when the shadow crosses over a certain crater on the moon, and for some reason, and they still don't know why to this day, the shadow varies from eclipse to eclipse, and it really shouldn't, because the shadow of the Earth should be the shadow of Earth. It shouldn't change, and I think what's going on is the upper atmosphere is probably causing differences in the size of the shadow depending on what's in the air. During the time of a high number of volcanic eruptions, it throws a lot of material in the air, and it makes the atmosphere thicker and turns it redder, and that's why I'm hoping as we lose the rest of this moon, that bottom part's going to turn red. Right now we can do that, but then we're going to lose detail in the part that's up on top. We can show that orange in the bottom by, let's see if I put this on auto. There it is. Yeah. In fact, actually, we can leave it right there right now. We can leave it like that. We lose the detail on the upper part of the moon, but that doesn't matter. Let's just leave it there, and we can start to look at that nice red color. Let's bring this up. This is the tracking of my mount. This is the lesser of my two mounts. This is just a quick throw in the car mount to use on a quick whim and a quick notice. It's not as good as my Atlas EQG that I use every night for my good videos. Okay, and the interesting part of this, there it goes, it just grabbed and went a little too far on me. Notice the bottom left-hand side of the moon is darker than the rest. That is because that is the first part of the moon that entered into the shadow. It is also the part of the moon that's going to be closest to the central line of the Earth's shadow. So when the total eclipse takes place, and this mount is taking a little bit of time to catch up and go back the other way. Come on. There you go. There it goes. Okay. It's got a little backlash in the gears. The bottom half of the moon is actually closer to the core of the shadow, so it's going to be darker. And the upper part is going to be farther away from the center line of the shadow, and that'll be brighter. And that'll determine how much color and how bright the color is when totality takes place. And we are now roughly 3 to about 4 minutes away from totality. So we got a couple more minutes to go.
So when was the last time that this happened?
The last eclipse, I believe, was last April. I think it was last April. We've just gone through a series of eclipses, about almost 1 to 2 a year, and it's happened fairly regularly for a number of years. But now, after this eclipse, there's not another one visible here in the northeast. I think it's about 2 or 3 years for the next one. So they're going to be spaced farther apart now. And it goes through cycles like that. And it's just the orbital mechanics of the Earth and the Moon. Down the other end, who do we have down there? What's your name?
Caitlin.
Caitlin, I don't know, can you hear Caitlin?
Hello.
Okay, this is fun for me, guys, because usually you hear me running my mouth for a half an hour all by myself. So this is fun. I've got some people I can talk to here tonight. I don't go drive myself nuts and you guys with me. So, and wondering how many other people are out there taking videos tonight. Be interesting.
A lot, probably.
Yeah, probably a lot. It's interesting. I follow a couple other sites, and they have some very odd views of the moon. I won't call the sites out by name because I don't like to do that. Everybody has the right to have their own view of what's going on, but I've checked a number of sites where there are people say the moon is not even a real object, it's a hologram and things like that. I mean, it's just being an amateur astronomer for 60 years, I know they're totally wrong, but hey, if that's what they want to believe, I mean, that's their choice. I can't tell them any different. And there's the last video I did, there was actually a fellow that contacted me and wanted to use one of my videos. He has an event that he observed on videos which he calls the lunar wave. And what it is, it's a line that goes up through the image and crosses the moon. And to me, it's totally electronic. It's nothing to do with the moon. And one of my videos actually has it. And I think it's just something that's inherent with these video cameras. And periodically you'll get a wave that runs up through, and I think it's just electronic noise. Well, he believes it's actually something physically taking place on the moon, and of course I don't. It's not anything. And he actually claims that he has people that say they've seen it visually. Well, I've been an amateur astronomer for 60 years, and I've never seen it. And what I think people are confusing it for, if you look through the telescope directly, you'll actually see wavering. It actually looks like it's moving around. In fact, if you look at some of my other videos on my site, in the close-up picture of the videos, you'll actually see them. You'll actually see them wavering. And all that is, that's the mixing of cold and warm air inside the telescope tube. It's like looking across the hot road in the summertime, and you see that wavering. And I'm sure people are seeing that, and they're calling that the wave. I think that's what's going on in that case. But that's my view. They have their views. Everybody's entitled to their own, so I'm not going to argue with them. I'm just going to say that I don't agree with them. The one thing I didn't like is I gave him permission to use the video, but I also said that make sure that I don't say I agree with your views. And he did give me credit. My name comes up, and he calls me out by name and all, but he doesn't specify that I don't agree with him. But so what? So it's just that I don't particularly like my video coming up on his site. It's kind of like I'm endorsing his view because he doesn't specify that I don't agree with him. But so what? It's not a big deal. Notice now we're really got just a little piece left. And according to my watch, we are at totality, but there's still an awful bright edge to that moon. That'll stay there for a little while until the moon enters more deeply in. And let's see if we can boost up some of this. That's an automatic. What happens if we go off of automatic and try boosting up some of this intensity? Let's see if I can bring up a little bit more of that. I don't know if we're going to be... There we go. That's a little too much. It's tough. Nice. It's tough. Let me see. To the eye, wow. Yeah, this is a fairly dark eclipse. To the eye, it's really. I mean, you can see that bright edge, but the disk itself is very dark. Now we've got a real bright light here in our eyes, but still, this is one of the darkest eclipses I've seen in a long time. That is a very dark moon. That is dark. Now, I have not heard of a lot of volcanic activity because that will tend to cause an eclipse this dark. There may be more activity around the Earth than I know. Well, yeah, those wildfires out west, they will add smoke to the atmosphere too. Yeah, that would affect it too. But that looks more dark than I'm used to. I'm used to them being brighter than that. And then if I go with the color intensity, yeah, that's just going to blow it up and just make it grainy. I don't want to go too high with that. Now notice the upper part of that is blue. There's a bluish haze to that upper edge. Yeah. That's because that's farthest away from the shadow. Even though it's in full shadow now, it's near the very edge, so it's still much more bright than the rest of the moon. We're going to let this run for a bit, let's see, we're 10 minutes into this video. I'm going to let it go for a while. I will end it then, and then I'm going to take some stills that I can process myself. And then I've got to break all this equipment down and get my rear end in bed because my wife and I are off to Florida tomorrow morning, and I was not planning on being out here all this time tonight because it was supposed to be cloudy initially. So.
Yeah, it was supposed to rain or something.
Well, no, well, yeah, there was supposed to be a chance of showers, but that high pressure system that's been sitting over us all week and holding that rain down to the Carolinas has continued to hang on and pushed all that stuff south of us. And so here I am, imaging the moon, where I thought I'd be in relaxing tonight, getting ready for my trip tomorrow. Let's see, we might go. I gotta remember which way.
It's a very clear night.
Yes. Yep. Notice, yeah, you can actually see the detail. That round area up there on the top is Mare Crisium. Down in here is Mare Tranquillitatis, and below that is the Mare Serenity. Right in this area right here, I'm pointing at the screen. As I'm pointing to my visitors with me here tonight. That's where the Apollo 11 spacecraft landed, the first landing on the moon, right about in here, that area right there. But
Still got a little light in there.
yeah, that whole upper half is going to remain brighter than the rest of the disk. This lower half is closer to the center line. If you think of the Earth's shadow as being like a target,
Yeah.
okay, and this part here is still missing the center, but it's closer to the center. It's about right here, where this half is way up here. It's almost at the edge of the shadow. So this part here, even though it'll probably go all red, it'll stay brighter than the lower left-hand side there. And yeah, as you can see, it's the orientation on the screen is off compared to the visual of the eye, and that's nothing more than the way I have the camera on the telescope. If I take that camera and rotate it, I could rotate it and get it to look the same as it does in the sky. Yeah.
Now, how long is it going to stay?
Totality lasts until 11:23. So it lasts about a little over an hour. So it's got about an hour to go, but we're not going to run that long. I'm going to run this video up for a few more minutes. I will then end it, and like I say, I want to do some individual snapshots in my other program that I can process through a program called Registax, and that'll be it. I won't wait for the whole eclipse to end. It's getting late.
How long will it be like this?
Well, like I just said, this part total, this will start coming out of the other side at 11:23, and partial eclipse ends at 12:27 a.m. And the last view of what they call the penumbral shadow, which is the very, very outer part, will last be visible around 12:55, 5 minutes of 1 in the morning, and it'll be all over. Okay, now you're in college. You're a junior. You're again. Your name is?
Caitlin.
Caitlin. Caitlin's in college as a junior. You are?
A sophomore in college.
You're a college also?
Yeah.
I am getting old. What year are you in?
Sophomore.
Sophomore? And where do you go?
I go to Northwestern in Winstead.
Oh, wow. Okay,
Yep.
Northwestern, yeah. I went to talk to community.
Yeah, I went there for one semester.
Did you? Yeah, I went there after I got out of the Navy.
Okay.
I was a dummy. I wanted to be an astronomer.
I don't think so.
I really wanted to be an
That
astronomer.
would be really cool.
And
Well, I'd say you accomplished that goal.
well, as an amateur, I'm strictly amateur, and I've done research work as an amateur, but I never made my goal. As soon as I hit my first college course as a freshman in high school, I knew that was it. That was the end of the road. There was no way I was getting a degree in astrophysics.
The next best thing.
Well, amateurs. One thing about an amateur is you don't get paid for it. You do it out of the love of it. But we get to work on anything we want.
Yeah, I think it's better that way.
A lot of these astronomers will go to a university like Wesleyan over here in Middletown,
Right.
they have a 20-inch Alvin Clark refractor, which is a beautiful old antique telescope. But they do basically what's called stellar parallax work. And what that is, that's measuring angles to nearby stars. On one side of the Earth, they'll take a measurement June 21st, say. Get over on the other side, December 21st at the other solstice, and you get two angles. You know the distance across the bottom, and of course you know from basic geometry, then you can figure the distance to that star. As long as you can get measurements, the stars have to be close enough to the Earth so you get a different measurement on each side of the sun. That's how they first determine the distance to the nearby stars. And then it gets into variable stars, my research, and certain variable stars are always at a certain brightness, and when they're at a certain stage. And if you could find one of those and measure the parallax to one and see how bright it appears to us, you can calculate how far away it is to appear that bright. So, but that's what they call using a standard candle. And then they can start calculating how things are. They'll find one in another galaxy way far away, and they'll find one of those variable stars. Okay, and they say, okay, now it's that dim, so it's got to be X amount of miles away to be that dim, and that's how they figure out how galaxies are that far away from us.
Oh, wow.
So,
I knew that.
but that's that's the heavy stuff. That's the stuff that's the stuff I never got. I studied variable stars, the brightness changes in variable stars, and I hooked on to one in particular called DQ Hercules, and I did a 2-year research project on that one, and I supplied information that was not being done by anybody else, as it turned out. It was a nova that occurred in 1934, and it was well covered for a couple years. An astronomer by Merle Walker studied it with a 200-inch in the 1950s and did some work on it. But nobody was doing it. Every 4.5 hours it will go through an eclipse. It's at a certain brightness, and it's a double star. And one star rotates around and comes in front of the other star. It's dimmer. It cuts the brightness off, and there's a big drop in the light curve that comes back. Yes, I did work. I had a photometer. And there's a program. I did it on the computer, and you run it through the program, and the program plots out the light curve. And I actually found a variation in a light curve that had never been studied. So I studied it for 2 years, and I supplied the two groups I was working with, the Center for Backyard Astrophysics with Columbia University and a group called the American Association of Variable Star Observers. And all that data is in their database, and hopefully someday will use it to figure out really what's going on. I'm an amateur, I don't know. My suspect is that there's a ring or cloud around that star, and as it moves away and starts to uncover the other star, there's a thicker portion of that, which is like a nebula, which is covering up that star and slowing down its brightness when it comes out. Because what it does, it goes through it looks like a V, a beautiful drop and a beautiful climb back to maximum. But when it hits the bottom and comes out, for about 2 or 3 minutes, it sits on like a shelf. It just sits there for 2 or 3 minutes. It doesn't change any brightness. And then all of a sudden, it goes right back to its gaining its brightness again. And it's something that I picked up that had never been noticed before. So, yeah, that and $1.50 will get me a cup of coffee today. So, but it was fun. So, anyway, okay, I'm, let me see, 18 minutes in. We are pretty much, let me see, middle of the eclipse is, mid-eclipse is 10:48, so we're about, around 20 minutes or so away from that. So we're going to cut this off here in a minute or so, and I'm going to go take a couple of snapshots and end this for the night. Really glad to get this done and get it up for you guys to see. Especially glad for the visit of the young ladies here tonight. That was very special, and my neighbor here.
Thanks for having us.
Well, you're welcome. It was nice to work with somebody instead of sitting out here all by myself for a change.
We got a nice little astronomy lesson.
Usually, as my people from my website know, my YouTube site, I have a pier up at my son's house up on Prospect Street Extension.
Okay.
And I usually work up there, and I run the wires from my telescope and this computer. I run it into the car. and I sit inside the car and control the telescope. And I'm usually nice and comfortable instead of sitting outside.
Yeah.
And when I used to have my house in Thomason, of course, I had my own observatory. I built
Right,
myself. And I was always worked in a warm room, so that was always nice. So this is a little bit of a change. This goes a throwback to my early days when I used to work outside as a youngster, and I never minded the cold. Never bothered me, but getting a little too old for that now. But there's some real nice color. That's a real copper red and that is dark. I mean, that left-hand side on the screen is almost invisible. Visually to the eye, it's there, but it's very faint. This is a very dark eclipse. Very dark. Very interesting. So, anyway, I'm going to say adieu again, and thank you, young ladies. I really appreciate having you. I mean, it's nice to have somebody to talk to with this, and it's nice to get some young people involved with it. So, and I hope you out there enjoy it. I hope you enjoyed watching this, the end of this eclipse with us, and we'll see you in a little bit. I'm going to be gone for a couple weeks, going down to Florida to visit my son, who moved away 5 years ago because of his job, and my wife and I are going down to enjoy a nice little time in Florida. I hate the heat, so I hope it's not going to be too hot. But anyway, I'll be back with you soon. Like I said, I have some CCD work I want to do first, but I will get to some more lunar videos. So we'll talk to you people soon. Good health to you, clear skies, and don't forget, get out there and enjoy the night sky. It's free, folks.